Hello everybody, this is Abraham with North Shore Computer Services, and what I have for you today is something unusual. However, it is related to the computers. This is an instant water heater, and this is a disassembled part. Let's see, here are the more parts for it, and some more parts over here. So some more parts. Here's the brain of the system. Here's the controls of the system. So it's a Richmond instant water heater. And this is a second one, which I purchased online as a broken unit for parts. These units are about $1,500 plus installation. So they're not cheap. And when it breaks, you want to make sure that you can fix it. Mine, the one I have in the house that I'll show later, is broken. And what happens is you turn on the water, it goes hot, and then goes out and goes cold, and then goes hot again and cold again. Then you can turn off the water and then turn it back on. Sometimes it stays hot, sometimes it's unpredictable as to when you can have hot water. Now my unit was working for about 10 years at least. So, I'm forgiving it for the fact that it's still working, but it's got a little problem in it. And what I have found out is very interesting. I think I solved the problem. I'm not sure yet, but I did use the parts from the donor unit, and I will go over those parts a little later. There is an interesting component in here that has nothing to do with my problem, but right here, I thought it was causing the problem. This little turbine, you can see there's a fan inside, spinning. This sits inside of the water inlet, so it's in there. And as the water goes, it spins. I thought, well, maybe this is what gives bad readings to the unit, and this is the connector to the main unit to see if it's going to, how it's going to react if it's disconnected. So once I knew there was something like this, because how else are you going to measure how much water is going into the unit? So the more water, the faster this spins. This probably these things are magnetic, most likely, because what I found on here was a piece of metal right on one of the blades. So this is magnetic. This is probably reed sensor, and it just goes like this, and the faster it goes, the more water. So I thought maybe somehow this is causing. So I disconnected it. The unit would not work at all. So I thought, no, this is not the unit, not the cause. I took apart each of the actuators, and they would not be bad, because if actuator went bad on a unit, you would not have the situation that I have, where it works most of the times and sometimes it doesn't. Something simpler had to be found, so I kept looking and looking, and this has been going on for a couple of weeks now. So we've been quite agitated by not having the constant hot water flow, proper hot water flow. I looked at the circuit that controls it, and I didn't find anything. I mean, it's hard to say by just looking at it whether there's something wrong with it or not. This is the inducer motor. So on this unit, the donor unit, there was a leak, and apparently the leak wasn't, I don't know what they did, but the motor is shot. There's water inside. In fact, there's a lot of stuff that got damaged by the leak. So if you have a leak on your unit, open it up, get the cover off, and vent it, and see if you can get the leak fixed. So apparently this is what caused the leak. These units are highly sensitive to the type of water you're using. If you do not have water softener, you're going to have problems like this. So this stands vertical. So it was the water was coming out of here, leaked all over the circuit board, all of the actuators, the inducer motor. So it really did a lot of damage to this unit. But the parts I needed weren't damaged. Okay, we're gonna go home and see the actual unit. I needed to get some parts from this unit, so we'll see you in shortly. Here are some instructions that I've downloaded for troubleshooting the heater, and the code that I was getting originally was code 12, which is a bit misleading, which says that it had the flame and then flame was lost, which would lead me to believe that little water amount of water sensor or water volume meter was not functioning properly. I took the circuitry from the broken unit, which worked, and I was getting a slightly different code, which was code 11. Code 11 means that the flame rods are at fault. So I'll see you shortly. Here I am going home. The bad unit or parts unit was at the office, and the unit that I'm fixing is at home. I didn't want to bring the parts unit home. I don't really have any tools at home to get that fixed, so I took it apart at the office, and I thought, whenever I need to get a part, I could just run over and get it, and that's what I'm doing right now. Today I thought I will grab the bull by its horns and try and fix the unit. So I've been running back and forth quite a bit. It would have been easier if I had all the parts at home, but like I said, I don't really have too many tools at home to get that fixed. Alright, so here is the home unit. It is installed, everything is connected, and it actually is plugged in. So these are the evil Knievels that caused the issue. This is what they look like. Let's see here. The instructions have said to clean them. Well, I went and I used the metal brush on them, and they stopped working completely. These look like pieces of metal, but really they are a little more complicated than that. Apparently these things tell the computer controller that the flame is present, and there is 3 flame dealing rods. Okay, this one here is an igniter. This is what turns on or flames up the gas, and this tell that the gas is present. And if these tell that the gas is not present, in order for the unit not to explode, the unit automatically shuts off the gas. It's a preventive feature, and a lot of this stuff in here, like this stuff, this is all to prevent overheating. There's a lot of sensors that say how high the temperature everywhere is. Because this unit is dealing with gas on on-off basis, it is very careful with telling or measuring the safety and not to cause internal fire. And that's basically what the situation that I'm dealing with. The unit works, but it senses something that's dangerous and it shuts itself off. All right, I'm gonna take these two out, and what I was getting at the office were these things. They're spacers so that the flame wouldn't go inside of the unit. As you can see right now, they're wiggling too much because they're designed to be used with those things. This is what happened to the originals. For some reason, the parts unit had these in good condition. It is a newer unit. It's only a year old. Developed a leak, like I said, and damaged itself beyond repair. Mine is over 10 years old. I don't know if that's why my things have disintegrated. I'm not sure, but that's basically what I'm dealing with. I'm gonna take those out and put the spacers in. This is what I'm doing. This is made from flame retardant material. Not really sure what it is, some kind of glass stuff. And I'm just gonna put it in and then put the this thing, the flange, back on and hold it tight with screws. I put everything back in. As you can see, it's nice and tight now, nothing's wobbling. When I had it on with no gaskets, a lot of heat was coming out because there were holes between them. Let's see how this will work now. We should put protectors on like that. This whole area is dealing with high energy, so a lot of protection. In fact, this whole unit is dealing with a lot of heat and a lot of water and a lot of electricity. Quite dangerous combination unless you have the covers on. All right, I connected everything. Moment of truth. Here is the controller, and let's see how it's gonna go. I got a special valve here. Flames up. Here that as I increase the water flow, the speed of the inducer motor increases. Also, if I decrease it, you'll see that only half of the flame will be working. No flame here. You just switch to a half mode where only half of the I don't know what this is called, where it produces the flame, is working, so you save energy. So if I increase the flow, water flow, the unit goes to full strength. And so far, no flame outs. This is the maximum water flow. It's been a couple of minutes, it's still running. Just shut off the water, and right now it's cooling itself off. so as to not to overheat. I'm gonna go over some basic functions here. This is the exhaust. This is where burnt gas goes out to, intake. But intake really, it takes the air from here. So now that I have the cover off, the intake really doesn't do anything, because it simply gathers air from here, which sucks and cools the unit, as well as sucks from the outside. So the intake air doesn't have to be really provided. You could just leave, if you're installing, you could just leave this off. Make sure you put some kind of grid on there so the dirt doesn't go in there. This is where the hot gases accumulate, and this is where they also put some water reheater. So the unit uses all of the available heat to heat the water. So this unit here is the actual heat exchanger, where the water goes in, the flames make the water hot, and in here they're just using whatever warmth left over to use up as much as possible. This plastic here is simply for overheating, so if the plastic melts and the contacts are broken, the unit will shut off. Flame rods, these are the prime suspects. If you have issue with your water heater, if you have something similar to this, which is Richmond or Rheem, I don't have Rheem here, but same company. If it works most of the time, these are your issues. Flame rods. Electronics, for the most part, is not going to be broken. It is very well insulated. As you can see, there is a silicone covering everything here, so even if it gets some water on it, it wouldn't be damaged. What they should have done is they should have made some holes for breathing. The rust that you see on my unit does not come from water leakage, but actually condensation that occurs because of the rapid heat exchange. Now condensed water goes into the tank here. I don't know what this tank does, got too many pipes going out of it, but when the unit is running, there is always condensation running into the sump pump, and this is what was causing the issue. The condensation was accumulating on top, so one of my pipes was not designed correctly. The angle was too sharp, and the water was leaking here on top of the unit. You can see some rust over there, then somehow seeped through the unit, and thankfully did not damage any of the electronics or any of the internal components, and then accumulated at the bottom. There wasn't a lot. Here's, you can see where it was coming from the top and leaking to the bottom. There wasn't a lot of water that was leaking here, but dear manufacturer, can you make this out of a little bit less or more rust resistant material if you're watching? At any rate, or better paint, you know. This is dealing with water, and it's gonna have some water. I have gotten a replacement. This thing, it's very heavy, got some stones in there, don't know what that is, but mine's okay, but it's got a lot of yellow stuff in there, so I'm probably gonna replace it someday. All right, at the bottom, maintenance wise, this is one of the most important things. This is where your filter resides. Do clean it out very frequently. On the unit that I received, the filter was never pulled out. So when I tried to pull it out, it actually broke inside. I can't get the filter out. I thought I would have a spare filter. No. This one needs to be cleaned monthly at least. I have the water softener, and my water softener is 1,000,000 years old. It is not efficient at all, but it does really good job on cleaning water. I do not have any calcium deposits anywhere in the system, and that way I know that this unit is running fairly efficiently. I did call the manufacturer and asked them for repair instructions, which they gave me. And one of the instructions that they gave me was to clean this unit using vinegar. One of the things that they should have put in the repair manual is in here on the water intake there should be a service valve, something similar to this, which would have been extremely helpful to do the cleaning with the vinegar. So you shut off the main water supply, you connect the bucket full of vinegar with a pump, and you circulate it through the unit for about 2 hours. So I would have the the vinegar coming out over here, and I would have the vinegar intake in here. You do not turn the unit on, you use the external pump for circulation, but that cleans out the unit, and I understand why. If you have lots of calcium in the water, this unit is very delicate. There is a lot of controls with the water control. A lot of solenoids, a lot of motors that turn water on and off and control it, and also very fine veins inside of the heat exchanger. So you do want to have this unit clean. Might want to also consider putting in a whole house filter if you're running this high efficiency unit. We don't really have a problem with calcification, so don't really have a problem with the unit. And in my case it was these guys, the flame rods, and these guys, the gaskets, flame retardant gaskets. Alright, if you have any questions, please submit them down below. Give me a like if you like what you see. This is highly unusual, but it is computer controlled, and it is something that I do want to fix myself. It is something very expensive and very hard to replace. So fixing it, finding the problem is of main concern, and saving money as always. I have purchased the parts unit for about 40 bucks, but it cost me about 70 bucks in shipping, so overall about over $100, which I think at this point money well spent, because I do have quite a few spare parts. The things that were broken on it are of no consequence to me, they're not important. I have all of the actuators which I checked and they work. I have all of the solenoids, and those things do work. And this board that I have in here, that's actually from the parts unit, which I wanted to test. I knew my board was okay, but I wanted to test the parts unit to make sure that that one was okay. So it seems to be okay, and it's that's how it goes. To save money, you gotta really think hard. So again, if you like my videos, give me likes. If you want to subscribe, please do. Enjoy and save money as always.